Bismillahirrahmanirrahim. Assalamualaikum dan salam sejahtera. Saya Madam Tunku Aina Marshidah binti Tunku Hassan. Akan mengendalikan untuk program Lepton Meka pada siri kali ini. Jom kita bersama-sama untuk discussion pada minggu ini. For this week, we're going to discuss chapter 2, mechanical wave. So list of equation, refer to number 1, and we use y equals to a sine omega t plus kx if the wave and our progressive wave travel to the left. Our progressive wave travel to the left, so we use positive kx. Point number 2, y equals to a sine omega t minus kx. Minus kx. If the progressive wave travel to the right, so we use minus kx. Point number 3. How to calculate velocity of the particle. Remember how to calculate the velocity of the particle in the progressive wave, which is travel to the left. So we need to differentiate displacement of a particle from equilibrium position and dy dt. We need to differentiate displacement of a particle from equilibrium position. So v equals to dy dt. So for velocity, so we differentiate, for point number 3, the velocity of the particle in the progressive wave travel to the left. So from refer to number 1, y equals to a sine omega t plus kx. So differentiate this equation, you get number 3. Differentiate dy dt a sine omega t plus kx. So kita akan keluarkan kita akan differentiate respective to t. So cikgu keluarkan omega, akan bawa ke depan. So omega dibawa ke depan, so saya jadi a omega. Differentiate sign. Differentiate sign, get cos. Remember, let's say I have tips here. Differentiate sign, we have positive sign, positive cos, positive sign, positive cos, negative sign, negative cos. For differentiation anti-clockwise, differentiate positive sign, we get positive cos. For first equation, y equals to a sine omega t plus kx, to get the velocity of a particle for the progressive wave which is travel to the left. So we differentiate this equation. So omega bawa ke depan. So inilah omega bawa ke depan. Differentiate sign, we get cos, and then copy the bracket. So omega t plus kx. Next, how to calculate the velocity of the particle in the progressive wave which is travel to the right. Refer to equation number 2. Equation number 2, we have a sine omega t minus kx. So first, we to differentiate y. So refer to t. So constant t kat sini omega. So differentiate dy dt. So saya akan keluarkan omega, bawa ke depan. So equation 4. So omega yang tadi saya bawa ke depan. Differentiate sign, kita akan dapat cos. Copy dalam bracket. So dalam bracket kat sini omega t minus kx. Right, so equation 5. To calculate velocity of the progressive wave. Just now we calculate velocity of the particle. Now I want to calculate the velocity of the progressive wave. So to calculate the velocity of the progressive wave, we use formula v equals to f lambda, which is travel to the right or to the left. So for the progressive wave velocity, we use equation v equals to f lambda. Okay, now refer to this slide and question 1. A progressive wave is described as y equals to 2 sine bracket 2 pi and bracket t over 0.4 plus x over 8t, where x and y is in meter, t in second. Determine the maximum value of dy dt at x equals to 0. Okay, what does this value refer to? Okay, now we proceed to the next slide. Okay, look at this equation. Okay, I will show you how to expand the equation first. Okay, first step we expand the equation. So 2 pi will times t over 0.4 plus, okay, next 2 pi times this x over 8t. So after expand, so you get your equation y equals to 2 sine, okay, 2 pi times t over 0.4. So 2 pi over 0.4 t plus 2 pi times x over 8t. So I get 2 pi over 8t x. Okay, next, differentiate dy dt. Okay, differentiate dy dt. Before we differentiate, we need to compare first. We generate equation. Y equals to a sine omega t plus kx. Okay, so what is your amplitude? To do what? And remember from the previous slide, okay, y in meter, t in second, x in meter. Okay, so your amplitude is 2 meter. Okay, omega, angular frequency, 2 pi over 0.4 radian per second. Wave number, 2 pi over 80 radian per meter. Okay, we go to our question. Okay, we want to differentiate equation dy dt. Okay, we differentiate respective to t. So dy dt, okay, copy equation first. 2 sine 2 pi over 0.4t plus 2 pi over 80 x. Okay, so we differentiate respective to t. Okay, so find your t. Okay, so 2 pi over 0.4 saya akan bawa ke depan. Okay, so bawa ke depan. So dia akan jadi 2 pi over 0.4. Copy number 2. Differentiate sign. We get positive cos. And then copy all in this bracket. Copy 2 pi over 0.4 t plus 2 pi over 80 x. Okay, so this is our dy dt. Okay, so what happened at x equals to 0? Okay, at x equals to 0, at x equals to 0, at x equals to 0, now your equation become dy dt equals to, okay, simplify your equation. 2 pi times 2, 4 pi divided by 0.4. 4 divide 0.4, your answer is 10 pi cos, copy, 2 pi over 0.4 t. When x equals to 0, we substitute this x equals to 0. So 2 pi over 80 times 0 is 0. So this is our equation of dy dt at x equals to 0. Question asked, okay, what is the value of dy dt at x maximum? Okay, so when dy dt is maximum, dy dt will be maximum at our cos theta. Okay, our cos theta is equals to 1. Okay, dy dt equals to 1. Okay, so dy dt maximum at cos 2 pi over 0.4 t is equals to 1. Okay, here. And for this bracket, dy dt is equals to 1. So your answer dy dt, okay, dy dt, okay, here maximum at 10 pi meter per second. So this is our answer. Dy dt is referred to the velocity of a particle. So this is the solution that we have discussed. Okay, so what does this value refer to? This value is referred to the maximum vibrational speed of the particle, which is dy dt is maximum equals to 10 pi equals to 31.42 meter per second. Remember, when dy dt is maximum, dy dt is maximum at cos theta, cos 2 pi over 0.4 t equals to 1. Now refer to question 2. Okay, figure 2a show the graph of displacement y versus t, and figure 2b graph y against x. Okay, of a progressive wave. From the graph, deduce the wave propagation velocity. B, particle vibrational velocity when displaced vertically 1.2 cm from the equilibrium position. Okay, so now, okay, we refer to the graph 2a. Okay, we have y against t. From the graph, what we can get? We can get value period. Okay, so period, saya bilang mangkuk, 1 mangkuk, 2 mangkuk. So period, okay, t equals to 4 second. Okay, next. Okay, graph y against x, displacement against distance. Okay, bilang je mangkuk. 1 mangkuk, 2 mangkuk, 2 mangkuk, 1 cycle, lambda here, we get 5 cm. Hanya bilang saja mangkuk. Okay, for 2 pi, period 4 second, wavelength 5 cm. Okay, so for question A, the wave propagation velocity formula V equals to F lambda. So what is the relationship between frequency and period? Frequency equals to 1 over period. Okay, so 1 over period substitute with 4 seconds. Then you get the answer. Okay, 4 seconds. So now your frequency is 1 over 4 Hertz. Okay, then look. So, okay, we go to the next. Okay, so we can use, okay, also you can use ratio 1.5 period equals to 6 seconds. So, t equals to 6 divided by 1.5, then you get 4 seconds. Next, from the graph y against x, 1.5 lambda equals to 7.5 centimeter. So for 1 lambda, 5 cm. So question A, calculate the wave propagation velocity and using the wave propagation equation. So we have V equals to F lambda, frequency 1 over T lambda. Okay, substitute with 5, frequency. Okay, 1 over 4. So we get answer 1.25 exponent, 1.25 centimeter per second. Convert to SI unit. So we have 1.25 exponent negative 2 meter per second. Now we continue with question 2b. Calculate the particle vibrational velocity when displaced vertically 1.2 cm from the equilibrium position. Okay, so vertically 1.2 cm from the equilibrium position is a value of y. Convert to meters. SI unit 1.2 exponent negative 2 meter. Okay, from the graph amplitude is 2 exponent negative 2 meter. So we can use equation to find the velocity of a particle. V equals to plus minus omega square root a squared minus y squared. So y is the current position of the particle. Okay. Amplitude 2 exponent negative 2. Omega, how to find omega? Okay, we have equation 2 pi over t, and here refer to here, omega equals to 2 pi over t. T is 4 second, and substitute, then you get omega 0.5 pi. Okay, substitute A 2 exponent negative 2, y 1.2 exponent negative 2. Tekan calculator, so you dapatlah answer 2.51 exponent negative 2 meter per second. So that's all for question 2. Okay, now we proceed to question 3. A progressive wave propagate towards positive x direction. Towards positive x direction. Remember, please highlight positive x direction. Okay, with a velocity of 5 meter per second. Velocity of wave. Okay, the amplitude and the wavelength are 15 millimeter and 40 cm respectively. Okay, 15 millimeter amplitude, wavelength 40 centimeter. Okay, question A, determine the wave equation. Okay, so you kena keluarkanlah dulu maklumat-maklumat yang penting. So kat sini highlight positive x direction. Okay, to take note. So we need to use minus kx. Okay, velocity of the wave 5 meter per second, amplitude 15 millimeter, wavelength 40 cm. Okay, so question B, we go to question B. Okay, question B asks to calculate the vibrational speed of particle at the position of x equals to 0.5 cm. And t equals to 0.2 second. Okay. So now we go to the solution for question 3. Right. So information given. The direction of the wave propagation is positive x direction. V of the wave 5 meter per second. Amplitude 15 exponent negative 3 meter. Millimeter convert to meter. Wavelength 0.4 meter. Therefore, the angular frequency of the wave. Okay, why we need to find the omega? And because we want to substitute to this equation. Okay, y equals to a sin omega t minus kx. Okay, why minus? Because the wave is propagate in positive x direction. Okay, minus because wave is propagate to the right or positive x. Okay. On amplitude, we have amplitude. Amplitude we have 15 millimeter. Okay, so we need to find omega. How to find omega? Okay, first we can find the frequency first. From the equation V equals to F lambda. Okay, V equals to F lambda. Okay, so V equals to, how you get this equation? Okay, omega equals to 2 pi F. Okay, so F equals to omega over 2 pi. Okay, so then you get, then you can substitute omega over 2 pi, lambda 0.4. Simplify your equation. Next, you get answer. Our angular frequency equals to 25 pi radian per second. Okay, so you now have your angular frequency. Next, how to find wave number? How to find wave number? So we know that formula wave number k equals to, k equals to 2 pi over lambda. So what is your wavelength? 0.4 meter. So rearrange the equation, simplify your equation. So wave number, okay, so 2 pi over 0.4, 2 divided by 0.4, the answer is 5. Okay, so 5 times 5, 5 pi. Okay, unit for K is a meter, or you can write, okay, okay, K equals to 5 pi radian per meter. Why radian per meter? Unit for, okay, untuk 2 pi, unit dia radian. Unit for lambda, meter. So, unit for wave number is radian per meter. So, after you get value wave number, you can substitute here. K, substitute with 5 pi. So, next, okay, state unit. Y and X in meter, T in second. So, that's all for question 3. Proceed to question 4. Okay, a progressive wave equation is given as y equals to 5 sine bracket 100 pi t minus pi x over 15, where t is in second, both x and y in centimeter, and determine the velocity of the wave propagation. B. Maximum velocity of particle of the wave. C. The velocity of the particle at distance of 50 cm from the source at time t equals to 0.2 second. We need to compare with the general equation of the progressive wave. Okay, general equation, and y equals to a sine omega t plus kx. Okay, so from the equation, our amplitude A is 5, okay, 5 cm. Okay, omega is 100 pi radian per second. Wave number is equal to pi over 15 radian per meter. Okay, from the equation, equation A asks to calculate velocity of the wave propagation. So we need value for f and lambda. Okay, so for frequency, okay, we refer to the angular velocity 100 pi radian per second. Okay, relate omega with frequency. Omega equals to 2 pi f. So frequency as a subject matter here. So f equals to omega over 2 pi. From the equation, okay, omega is equals to 100 pi divided by 2 pi. Pi cancel, so we get answer 50 hertz. Okay, so that's our frequency. Okay, how about lambda? So refer to the wave number. Formula for the wave number, k equals to 2 pi over lambda. Okay, from the equation, from the equation k, okay, we get k pi over 15 as per centimeter, or we can write radian per centimeter. And from the previous slide, mentioned that x and y in centimeter. Okay, so k equals to 2 pi over lambda. Substitute wave number and pi over 15 equals to 2 pi over lambda. So from here, lambda equals to 30 cm. Okay, next we want to calculate the velocity of the wave propagation by using formula v equals to f lambda, frequency 50 Hz, lambda 30, substitute value, then we get answer 1500 cm per second. Okay, so we change to SI unit, okay, 15 meter per second. Okay, next, okay, we continue for B, and we continue for B. Okay, so we need to calculate the maximum velocity. How to calculate maximum velocity? Okay, we need to first step, we need to find the equation for the velocity of the particle. Velocity of the particle. So we need to differentiate this equation. Okay, differentiate dy dt and differentiate dy dt. Okay, differentiate dy dt. So, okay, first step, okay, you cari dulu dalam equation ni, okay, kita tengok yang mana ada kaitan dengan t, 100 pi. Okay, so 100 pi ni, cikgu akan bawa ke depan. Okay, yang inilah 100 pi yang kita bawa ke depan. Okay, then copy, amplitude copy 5. Okay, dia bawa 5. Okay, differentiate sign, differentiate sign, answer cos, and then copy dalam bracket. So 100 pi t minus pi x over 15. Okay, so simplify your equation. Okay, dapatlah kat sini. Okay, so saya dapatlah kat sini 500 pi cos bracket 100 pi t minus pi x over 15. So when the velocity is maximum, velocity maximum when this cos theta or cos 100 pi t minus pi x over 15 is equals to 1. And so your answer will be 500 pi equals to 1570 centimeter per second. Next, we change to SI unit and equals to 15.70. Okay, or we can use formula V max equals to A omega. Okay, from this equation Y, okay, amplitude 5. Okay, so we substitute amplitude with 5. Omega. Omega is 100 pi. So we substitute omega 100 pi. So we get answer same as above. 15.70 meter per second. Okay, next question C. Calculate the velocity of the particle. Okay, calculate the velocity of the particle at distance. Distance is x. Okay, 50 cm from the source at time t equals to 0.2 second. Okay, so from the previous slide, we have differentiate dy dt, which is referred to our velocity of the particle. So we copy again. So Vy equals to 500 pi cos bracket 100 pi t minus pi x over 15. So now I want to calculate the velocity of the particle at x equals to 50 cm and t equals to 0.t second. So we need to substitute x with 50 cm and substitute time with 0.2 times 0.2 x 50 cm. Okay, so now change your mode calculator from degree to radian. So in this bracket, so make sure when you use your calculator, your mode is in radian. Okay, so you get answer negative 250 pi, which is equals to negative 785 centimeter per second, or convert to SI unit, negative 7.85 meter per second. Okay, so now last question, question 5. Okay, figure above show a displacement y against x. Okay, y against x, where y is in meter, x in meter also. Okay, y against distance x graph after time t for the progressive wave which is propagate to the left. Okay, please highlight to the left. Okay, the frequency of the wave is 2 Hz. Okay, question A, what is the wave propagation of velocity? Question B, what is a particle vibrational velocity? And when displaced vertically, okay, 2.0 meter from the equilibrium position. Okay, so from the graph, refer to our graph y against x. Okay, our lambda is equals to 1 meter. Okay, from the information given, the frequency 2 hertz, wavelength 1 meter. 1 meter we get from the graph, frequency, information given from the statement. Therefore, the angular frequency is omega is equals to 2 pi f. Substitute value, then you get answer for pi radian per second. Question A, we need to calculate the wave propagation of velocity. Okay, for the wave propagation of the velocity, we need to use formula V equals to F lambda, frequency 2 hertz, lambda 1.0 meter. So, selesaikanlah. So, we get answer 2.0 meter per second. So, this is our wave propagation velocity. Okay. Now, last question. Question B. The particle vibrational velocity when displaced vertically, 2.0 meter from the equilibrium position. Okay, so the particle displaced vertically 2.0 meter. So this is referred to value y. Okay, using the wave vibrational equation, so we have equation Vy equals to plus minus omega square root amplitude square minus y squared. So omega angular frequency, and we know that frequency is equals to hertz. So angular frequency 2 pi f, substitute f with 2. Okay, then you get answer omega 4 pi radian per second. Okay, so we substitute omega with 4 pi amplitude, and from the previous slide, amplitude, okay, amplitude is 3 meter. Okay, amplitude 3 meter, and from the graph we get amplitude 3 meter. Okay, y substitute with 2, so given in the question, and when the particle displaced vertically 2 meter, then you compute your answer. We get answer Vy equals to 28.1 meter per second. And so typo here, and the unit should be 21.8 meter per second. Meter per second squared is referred to acceleration. For velocity, meter per second. So that's all for our program. See you again. Thank you.